Select the major product of the following reaction. If we look at the starting material for this reaction, we see that we have an alkyne, and specifically this is an alkyne that is at the end of a chain, so this is what we call a terminal alkyne. And we also have a benzene ring. And what we are reacting this with is 2 equivalents of hydrochloric acid. So we should first know that the double bonds of the benzene ring are not actually double bonds. We have resonance all around that ring, which means that the benzene does not undergo the same reactions that alkenes and alkynes do. So I will say that the benzene ring is not reactive to normal alkene addition conditions. So we expect that the benzene ring is not going to react. The terminal alkyne, however, should react with hydrochloric acid, and it will react in a similar way to what we saw with alkenes. So when we saw hydrochloric acid or hydrobromic acid adding to an alkene, these additions followed Markovnikov's rule. So Markovnikov's rule states that the hydrogen atom adds to the least substituted carbon of the alkene. So the hydrogen adds to the least substituted carbon. So for the alkyne starting material, so I will draw a generic terminal alkyne. That means that when we add HCl, this hydrogen will add to the carbon at the end because it is less substituted than the internal carbon atom. So we will see that the chlorine has added to the more substituted carbon and the hydrogen has added to the less substituted carbon. This haloalkene is not as reactive as a normal alkene and not even as reactive as the starting alkyne. So if we had only one equivalent of hydrochloric acid, this would be the major product. Since we have a second equivalent of hydrochloric acid, the reaction will continue. And the second equivalent will add also with Markovnikov selectivity. So overall, we will end up with 2 chlorine atoms attached to the interior carbon and 2 hydrogens that have added to the terminal carbon, which is the structure shown in answer D.